review before we get going on. Today I want to graph two functions. Okay? I want to graph a sine function and I want to graph a cosine function. Okay? But before I can even get into that, which some of you have already done, okay? Before we get into that, I want to talk just briefly about any old point. Okay? Like, for instance, if I said the point -3, 6. Okay? Where is the point -3, 6 in the Cartesian coordinate plane? Move all this. Can I move? Move with me. Move. When in doubt, you just got to come over here and do it yourself. So talk to me about where the point Now. So my point is at -3, 6. Where is that point located? Quadrant 2. How do I get to it? How do I get to the point -3, 6? This is not a trick question, I promise. From where? From the origin. Okay, so from the origin, I'm going to go left 3 and up 6. Right? Everybody agree with that? Love it. Okay. What does, in that exact same coordinate, that exact same point, what does, for instance, the 6 represent? Y value, right? Okay. What else does it represent? What do you say? If we were talking trig, then we would think sine. Yeah. Okay. But we're not right now. We're just in a regular old thing. Okay. What does it really represent? Distance of, or distance from what? From what to what? Not distance up from the origin, because that would mean it would be over here from my horizontal axes, right? Okay. So the 6 here is really the distance from the horizontal axes. What does the 3 represent then? Distance from the vertical axes, right? Wonderful. Love it. Okay? That's a little background check for us. Math thinking. Critical math thinking was what that was. Okay? Being able to take a problem and see, yeah, it means x and y, but really that's the distance above an axis and the distance left of an axis. Okay? All right? So, now, let's talk trig. Okay? Sine functions. We can be looking at the unit circle, or we can be at any point that we want. Okay? Oh, let's take one more step back. If I have a function, any old random function, what is the independent variable in that function? X. What I put into the function, right? Okay. So my independent variable here is X. Right? What's my dependent variable? Independent is what you put in. Dependent is what you get out. So what's my dependent variable then? Say it louder. F of X. Okay? Or we call it Y. Right? Okay? Love it? Love it, love it, love it. Now, let's go to trig. Sine function in particular. What is my independent variable? What do I put into a sine function? Let's say, look, I put in an angle. Okay? In a sine function or in a trig function, I put in an angle. We'll call it theta. What do I get out of the sine function when I put theta into it? This one's kind of a trick question. Let me go back up because we nailed this one. Plugged in X into my function, right? So that's independent. Got out f of X. That's my dependent. Sine function. Plug in theta. Get out. Well, what's my function? What do I get out? Here I plugged in X, got out f of X. In my sine function, I'm going to plug in theta, and I'm going to get out, say it louder, of theta. See it now? Up here, we put in X, right? That was our variable. Okay? We got out f of X. Okay? So in a sine function, I'm going to put in theta. I'm going to get out sine of theta. The same thing as is up here. It's just that we didn't write out the function. If we would write the function, you would have had it. Okay? All right? So on a graph, because that's what we want to do today, we want to graph the sine function and the cosine function, and that's probably all we'll get to. Okay? So on a graph, my horizontal axis is my independent variable, correct? So what's that going to be? Theta, my angle, right? Okay. So this is going to be theta here is going to be my horizontal axis. Vertically, what's my vertical axis going to be? Sine of theta, because that's my dependent. Okay, with me? Now, what I need everybody to do is I need everybody to come up here. I need you to grab one of these sheets. You need one of these sheets individually. Just wait until you hear this because you can probably grab one for your partner if you got one. And you need half of a spaghetti. Okay? So take one for the two of you. When you get there, then crack it in half. Okay? With me? Make it so. on spaghetti. All right, so we're going to graph sine first. So at the top of your page, you're going to want to say that this function is y equals the sine of theta. Okay? Right? With me? Now, refresh my memory. In trig, sine is what? Sine is y. And we just said that if we have a point, the y is really what? The distance away from the horizontal axes, right? So using your spaghetti, what you're going to do is you are going to measure the vertical distance above or below the horizontal axes that your unit circle at the bottom of your page is. So what I mean by that is, notice the scale up here. The scale is in 30-degree increments, correct? Okay, so I'm going to go down here and I'm going to find 30 degrees. Well, 30 degrees is this one right here, this is 60, and this is 90. Right? And they're actually by 15s down there. Now, tap the brakes. Okay? I want to get what again? If I'm graphing sine, what do I want to measure? The distance away from the horizontal axes. So I am going to measure the distance that I am off the horizontal axes. Then, what I am going to do is I am going to go up here and I am going to put a dot, that distance. So mark your spaghetti. That's your 30. Okay. And then, what?
Did you say party spaghetti?
No, spaghetti.
Mark your spaghetti.
Mark your spaghetti.
It sounded a lot like party spaghetti.
I like party spaghetti. With me? Okay. So then now you would go back down here and you would measure your 60. Degree one. With me? Rinse, lather, and repeat. Throw in some 45s every once in a while too. Okay? Because those are all on the unit circle then too. Okay? Go all the way around your circle. So you should have dots that look like this, correct? Okay? So then what we can do is now we can connect the dots, la 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 la, and it looks like that. What kind of a function is a sine, or what kind of a graph, I should say, is a sine function? Is that pattern going to continue? Okay. Likewise, if I would have went back this way, like that. Okay, so that pattern is going to always continue. Anybody know what those are called? Repetitive, continuous type things with waves. Those are called sinusoidal functions. Okay? Right? Is it ever going to get bigger than where we're at? No? Okay. Is it ever going to get less than where we're at? No. All right. My scaling was a little off. That's why I went down below -1, +1, but should have been right on. Okay. Right? So like here, it doesn't just go straight up because it follows the curve. Yep. Yep. Okay. All right. What I'd like you to do now is I would like you to investigate cosine on the back side of this now, doing cosine. Now my question to you is this. Are your marks on your spaghetti, are those going to change? No, they're going to be the same, right? Okay. But now, what are we measuring? Go down here. What am I measuring now? Because now cosine is what? X, which is? No. Distance from the vertical, right? Okay. So if I've got 30 and 60 and 90 and 0, right? My distance off of the vertical axes is this one. That's the one I want. This is the one I want. That's the one I want. This is the one I want. That's the one I want. Is here. And here. And there. And there. So my distances stayed the same. It's just now I'm measuring horizontally. What happens when I get to 90 degrees now? It goes to 0, and then what? It goes negative because now I'm on the left side. I'm on the negative side of my vertical axes. So finish that one off and tell me what that looks like. So you should have gotten a cosine function that looks like that. Agree? Now what you got? Should be what you got. Okay. So sine starts at the origin, goes up, right, until pi over 2. Then it goes down all the way, and at pi over 2 it's at +1. Then it goes down all the way to -1 at 3 pi over 2. Then it comes back up until what would be 5 pi over 2, and then keeps going, and then down and runs the roller coaster. Okay, cosine you load at the top of the big fall. Okay, and then the first couple of cars get over the hump, and then you go whooshing down. Okay, until you get down here at pi. At -1. Then you climb back up. Click, 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 click. Then you go back over. Okay? All right? Have a great weekend.